Good afternoon, class. I'm sorry for the technical difficulties we've been having. I think they've been mostly fixed, but I am pre-recording today's lesson so that you can get it no matter what happens. Today's lesson is about linear measurement. And linear measurement is extremely important in woodworking and construction because it deals with the measurement from one point to another, or across a line, which would be the root of the word linear. And it is vitally important that you master a system of linear measurement so that when you want to build something, or when you want to communicate how to build something with somebody else, you can actually dimension the wood or material correctly so that you can, build things that are square or that are of a certain length or that fit. And linear measurement has been with us for a long time. Since the first time, humans wanted to build things, they had to have some sort of system of measuring. And just like when you learn how to count, the first objects that you have that are handy to measure things are your body. So very often, humans would express how long to make something, a stick or a spear for killing something or whatever it is they wanted to make. It would have to be this long, as long as my arm, or as wide as both my arms spread out. And if you wanted to measure how far something was, you could talk about it in the number of steps that it took you to get from here to there. Say it took 250 steps to get to the water supply, or 500 steps to get to the good grouse hunting ground, or whatever it was. That was a very primitive system of measure. As humans evolved, as we began to develop a more centralized society, we had an agrarian society followed by an industrial society. We needed a system of measurement that would evolve to be more specific and, in fact, to be more precise so that we could build things better. There are two systems of measurement that are in common usage today. The one that I'm sure you're familiar with because it's been taught to you for years is the good old metric system. The metric system is wonderful. It is very simple. It's all based on tens. We have units of measure for linear measurements, like so for distance from point A to B. We have units of measure for volume. We have units of measure for pressure. And they're all based on tens, and so they all use the same prefixes, and converting between them is really easy. There are 10 millimeters in a centimeter. There are 10 centimeters in a decameter, which you never use. There are 100 centimeters in a meter. There are 1,000 meters in a kilometer. You guys know all this system of measure. It's very simple, it's very easy to use, and it has become the worldwide standard. Canada adopted the metric system of measure sometime in the early to mid 1970s, and it greatly simplified how we relate measurements as a society. In fact, almost the whole world has gone to the metric system, with one really notable exception. The system of measure that predates the metric system in most of the Western world is what we call Imperial Measure. And if you look at the word imperial, it just means dealing with the empire. And the predominant empire for hundreds of years, up until fairly recently, was the British Empire. So the imperial measuring system originated in Britain, and it basically took together all their systems of measure and lumped them together and said, okay, this is how we measure things, which means that it can be a little bit convoluted. We're going to talk specifically about linear measure, but they have a system of measure for everything in imperial. But there's no real interrelationship between them. And in fact, when we're talking about linear measure, it's a whole bunch of arbitrary measurements that don't necessarily work together particularly well. So back to my earlier point about dealing with linear measurement with the body. The sort of base unit of measure in linear measurement in imperial is the foot. And a foot, if you convert it to metric, it's about 30 centimeters long. And it is actually the measurement of a foot. And because they wanted to standardize, it was not just any foot, it was the king's foot. So the king was the actual measurement tool that you would use, which is inconvenient. You have to go and get the king. When we talk about units of measure smaller than a foot, an inch was the distance across the king's thumb. A yard was the distance from the king's thumb when he outstretched his arm to the tip of his nose. Which, I mean, these things seem ridiculous, and there's no way you're going to go get the king every time you have to measure something, so they standardized it to a degree. 1 foot became 12 inches. 1/12 of a foot was an inch. And when you wanted to measure longer distances, a statute mile, which is a mile on land, which is strangely different than a mile on water, called a nautical mile. A mile on land is 5,280 feet, which is not very convenient when you have to do math and calculate things. But like I said, the imperial system of measure is pretty arbitrary. In fact, I've written here that it is arcane, it is complicated, and it is necessary. Why? Why would we use imperial measure anywhere at any time when we have available to us a much better system in metric? And the answer is, the United States. The United States is one of only a couple of jurisdictions in the world that actually still use the British imperial system. Britain converted to metric a long time ago because they recognized that it was much simpler. And in fact, many parts of the United States have, not geographic part, but many industries in the United States have converted to metric. In fact, NASA uses the metric system because it is generally superior. But the construction industry still uses the imperial system of measure. And because Canada is the United States' largest trading partner and one of our biggest export is wood products, we have to adhere to their system of measure for all of our construction-related, products, drawings, etc. So it becomes important for us to learn imperial measure, even though only one country in the world uses it, but it happens to be a really large country. And if you want to do business with them, you do business in their system. So imperial measure is the de facto standard for all construction in North America, in Canada, the United States, probably in Mexico too, I'm not sure. So I want to discuss linear measure in the imperial measure system, and you're going to do some work with it, but I need you to get your hands on something. This is a ruler that is graded in the imperial measure system. So it's a 30 centimeter ruler. You're used to using a ruler of that length. And this one is actually graded in both systems. It has centimeters on one side, and on the other side it has inches. So it's marked in inches, and then each one of these inches is broken down into 16 equal parts. So I need you to get your hands on one of these. Hopefully there's one kicking around in a drawer someplace at your house. Maybe your neighbor's got one, maybe your uncle has one. If worse were to come to worse, they are available at the dollar store. I don't necessarily want to send you out there into the world to get one, but if you had to, you could source one. So I need you to get your hands on one of these. If you've got something different but you think it'll do, like a tape measure or something, just drop me an email and we can talk about it. But you need an imperial ruler. Now I'm going to discuss the imperial ruler, and we'll talk about the base unit of measure that we use in construction class. And because we tend to make projects that are a little bit smaller, we're going to use 1/12 of this ruler, or the inch. So 1 inch, I-N-C-H. We don't want to write I-N-C-H every time we talk about it, but we do want to communicate what unit of measure we are using. So when we short form an inch, it's 1 and then it's a quotation mark, just a regular, 2 pair of quote marks. I want to make air quotes around it, but that's what you need to abbreviate inch when you're writing about it. So I'm going to draw a ruler. I am not an artist, I'm sorry. I'm going to show you a picture of one in a couple of minutes. That'll be maybe a little bit clearer for you, but this is a ruler. So this is the 0 point. We'll call this 1 inch, 2 inches, and then it measures and it goes on. In the case of this ruler, up to 12. If you need to measure something bigger, we have a yardstick, which is a meter stick only graded in inches, or you could use a tape measure, which is a flexible ruler. So, if I'm measuring something, did I just turn off? No, I'm still good. If I'm measuring something that is 1 inch long, say it's that, I can say that that is 1 inch long. If I'm measuring something that is less than an inch, or it's longer than an inch but less than 2 inches, I have to deal with a fractional unit of measure. So I have to make sure I'm still recording here. Yeah, I'm still going. So I have to break the inch down into smaller parts. Just like a centimeter is broken down into smaller parts in that it's 10 millimeters, the inch is broken down into smaller parts, but it's not as convenient as 10. We don't use tenths of an inch. We use different fractions. The mark that is halfway between 0 and 1 inch on our ruler is actually 1/2 of an inch. So that's 1/2. So if something is that long, we say that it is 1/2 inch. If something doesn't fall easily between 0, 1/2, and 1, we break our inch down further into other fractional parts. So 1/2 of 1/2 is 1/4. And then 3 of these 1/2s of 1/2s is 3/4. If that's not precise enough, we break our inch up again. And this is an eighth. 1/2 of 1/4 is 1/8. That's an eighth of an inch. This is 3/8 of an inch. This is 5/8 of an inch. And this is 7/8 of an inch. If that's not fine enough for us, if that doesn't give us enough accuracy in our measurement, we can break the inch down even further. And this is the limit for our construction class. Generally, when working with wood, a 1/16 of an inch is a close enough margin. You don't need to measure any closer than that. But a 1/16 is 1/2 of an eighth. So we get each of these tick marks in between the eighths represents 1/16 of an inch. On your ruler, you'll see that it's broken down into little pieces representing 1/16 of an inch. On most rulers, the lines for 1/2 are the longest, then the quarters are second longest, the eighths are third longest, and the 1/16ths are short. You might find a ruler that just has all lines of equal length and you just have to count the 1/16ths, but it all kind of depends on what you have. So I'm going to show you how to measure something in Imperial in a fraction of an inch. So if we come across something that is that long, let's count that. So this long is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10/16ths of an inch. Problem with 10/16ths is that it's not in lowest terms. And if you go to the lumber yard and ask them to get you something that is 10/16ths of an inch, they'll actually be able to determine what you're talking about, but they might laugh at you because it's not in lowest terms. So 10/16ths, when we place this fraction, I know that's like the F word, right? Fractions, everybody hates them. When we place 10/16ths in lowest terms, it is 5/8. So this measurement is 5/8 of an inch. Okay, let's do another one. Okay, let's count our 16ths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It is 14/16ths of an inch. In lowest terms, 7/8 of an inch. Okay, lowest terms. If you don't remember your grade 5 math class where they taught you about fractions, I'm going to show you very quickly and easily how to ensure that your fraction is in lowest terms. This only works with these fractions. It only works with fractions that are divisible by 2, where the denominators are divisible by 2. Maybe don't tell your math teacher I showed you this, and certainly don't try and apply it to fractions that have a denominator that is not divisible by 2, which is half of all possible fractions, and because it won't work. But in this case, 14 out of 16. To determine if it's in lowest terms, just simply try and divide the numerator and the denominator, that's the top number and the bottom number, by 2. Okay, so 14 divided by 2, I can do it. It gives me a nice even number, 7. If it doesn't give me an even number, if it doesn't give me an integer, if it were, say 9, and I divided by 2, and I got 4.5, I couldn't do it. The fraction's already in lowest terms. So this gives me 7. What I do to the top, I must do to the bottom. So 16 divided by 2 is 8. Is that in lowest terms? Yes, it is. I know that, and you probably do too. But if you didn't, you could determine that it is in lowest terms by attempting to divide both numbers by 2. So 7 divided by 2 equals 3.5, which is not an integer. It's not a whole number. So this fraction is already in lowest terms. What about measurements that are longer than an inch? Let's pretend that this is on our ruler. This is 5, this is 6, and this is 7. And we were measuring something that is this long. That's pretty simple. I would put this number, the highest whole inch that it has passed, I put that first. So my measurement becomes 5 inches plus whatever fraction shows on the ruler. 1, 2, 3, 4, 5, 6, 7, 8, 9 sixteenths. Just doing a quick check, I can't divide 9 by 2, so this is in lowest term. So this measurement becomes 5 and 9 sixteenths inches. I have a sort of a fun assignment for you to do today. We're going to play a game. It's called the ruler game. I'm going to show it to you now. Classroom. You'll see that under measurement resources, I've put something called the ruler game. Click on the ruler game, and it'll open up in a new browser window. There are 4 versions of it. It's actually 2 versions and then 2 subversions. There's the metric ruler game. We're not interested in the metric ruler game. And then there's the inch ruler game. And the inch ruler game has a version that is better on computers and a version that is better on a tablet or your phone. You can play this until you get good at it. It is timed, so I hit Let's Play. With preferences, I'm going to turn the timer off here just because I'm talking and giving a lesson as well. But if you play with the timer on, you'll get better at it quick. Under increment level, set yourself to sixteenths. And then what you have to do is when you say start new game, it will give you a measurement 2 and 15 sixteenths. And then you have to go here on the ruler and you have to go find what would be 2 and 15 sixteenths and click on it. And it very happily gives you a point when you do that. So it gives you a score. I've got 10 points. Now it's asked me to choose a 1/4 inch. So I choose a 1/4 inch and it gives me 20 points. Now it's asking for 3/8 of an inch. I'm going to go over here and I'm going to click and I'm like, oh no, that was 3 sixteenths. I didn't choose 3/8. So your assignment for today is pretty simple. I think you've got about 20 minutes left in the class period. I want you to play the ruler game, and I want you to play the ruler game till you're good at it. If you're having trouble, I'm available for guidance, or should be, unless the internet is down. And then, just email me your problems, and I'll get them back to you as soon as I can. And I will see you tomorrow for class time. I am quite optimistic that things are going to work from here on in.